By following this step-by-step tutorial, users will know how to design and code check a pier cap using DXF reference in IDEA StatiCa Detail application. Launch IDEA StatiCa Detail and set up a new project using Detail 2D. Use General Input section, select Concrete Grade and Concrete Cover. Finish setting by clicking on Create. Start by adding a wall member by clicking on DXF Import. A dialog to locate and open the desired DXF file will pop up. After the selection of pier_cap.dxf, you will land in a dialog for selection. Select the part of the outline of the pier cap and click on Outline. Finish the selection by OK button. Do the same to import the upper part from DXF. The shapes of the wall elements have been generated by DXF, but the 2D DXF reference lacks the information about thickness, thus you need to adjust it manually. Set the thickness for both W1 and W2 members to 1.20 m. Right now, the structure is statically indeterminate, you need to add boundary conditions. To create line support, click on the Model Entity button and select Line Support Type in the Support section. To place a concentrated force into the pier cap, we will use bearing plates to distribute the load more evenly. To add one, press Model Entity button once again, and in the Load Transfer Devices section, pick the first, bearing plate. Change the width to 0.40 m and the thickness to 0.04 m, then the edge number to 3 and shift its X position to 0.45 m. After that, copy the bearing plate and change its position to be measured from end. Now it's time to add load case. Load case will be created by clicking Load Case button and it's for permanent effects by default. You need 2 load cases to distinguish between permanent and variable loads and 3 combinations to cover 1 ULS and 2 SLS combinations, characteristic and quasi-permanent, for all checks. Let's modify the automatically added load case LC1 for permanent effects. In the Load Impulses tab, click on the plus button and apply a point load. It will be automatically placed on one of the bearing plates. Input the required loads. Copy load case LC1 to create load case LC2. Delete self-weight, and change load case type from permanent to variable. Then modify the loadings for load case LC2. Create the first nonlinear combination C1 by clicking on the Combination button, and set it as ULS limit state. Apply the appropriate load factors. Copy the combination to create load case C2 and C3. Once again, apply the necessary load factors necessary for SLS checks. In addition, the option is available to check SLS the combination on deflection and crack width both for a given combination and individually. For C2 characteristic combination, choose active for deflection check and crack width for C3. Run the linear analysis by navigating to Tools ribbon and then clicking on the Linear Analysis button in the top ribbon. To see the most compressed fields better, you can set the filter for compression on -1.0 MPa in the top ribbon. Alternatively, you can use a more advanced topology optimization tool to see what the most effective reinforcement layout should look like. The next step is to apply reinforcement into the model. In this tutorial, we assumed that the user knows how to reinforce a pier cap and prepared some reinforcement in DXF in advance from drawings. Click on DXF Import and choose Group of Bars Entity. A dialog to locate and open the desired DXF file will pop up. After the selection of pier_cap.dxf, select all the polylines, rebars shape, you need. Finish the selection by OK button. The 2D DXF file transfers the global width of a polyline as the diameter for each rebar, but it does not contain information about the number of bars in the perpendicular direction, and we need to adjust them manually. Hold Ctrl and select all imported reinforcement, change the number of bars in a layer 10 and diameter to 20 mm. To finish the reinforcement in this example, combine the reference from DXF with reinforcement defined in IDEA StatiCa Detail. In this case, Add some horizontal and longitudinal reinforcement into the pier cap and a few layers of reinforcement representing the stirrups in the pier. Click on the rebar assembly button and select the first reinforcement item group of bars. Now the reinforcement modeling is complete. We now analyze the structure. Click on the Calculate button to run analysis. An overview of the analysis results will be automatically displayed. To go through the detailed checks of each component, start with the Strength tab. This will show concrete checks such as utilization in stress, principal stresses, strains, and a map of reduction factor Kc, which can be switched on the ribbon. For detailed results of reinforcement, you need to click on the row reinforcement. This will change the ribbon icons and unroll the table for results. You can display the results for strains and stresses in each bar and their utilization. All results can be displayed in the same way. Let us show the difference in the ribbon for SLS checks of stress limitation, crack width, and deflection. In IDEA StatiCa, customizable report can be generated and further reviewed.